Hello and welcome. This is Bijan Hoshiar. In this topology, I'm using a WRT300N Cisco home router to put at the edge of my local area network, and through that wireless home router get connected to the internet. I have total control on the devices that I have in the local area network, which could be a small office or a home office that I am working on or living in. These devices I have total control on. I can obtain their MAC addresses by performing ipconfig all. For example, on this device, if I go to the command prompt and perform ipconfig space/all, it gives me all the information that I need as far as IP addressing of this device, in addition to the MAC address or physical addresses. Notice that there is a wireless connection and a MAC address or a physical address related to that. That is the one that we need for this exercise. There is another one called 3G, 4G cell connection. It has its own MAC address, but our device is not connected to any cellular type of network in this activity. So we are not using that MAC address. Also, there is one called Bluetooth. We are not using Bluetooth connection for connecting to the home router. Therefore, that physical address is not useful for us in this activity. We need the MAC address for the wireless. Same is true for the laptop one. PCs have physical and Bluetooth. Let's take a look at it. ipconfig all. When we perform ipconfig all on this one, ipconfig space/all, you'll notice that there is a physical address, MAC address. That is the one that we normally use on PCs. Bluetooth connection is not there. However, it has its own MAC address. There is no cellular MAC address on these PCs because they are wired. They are not wireless. ST1 smart phone device 1 and LT1 laptop 1 are getting connected to the home router using wireless connection. Home router can act as an access point for wireless devices. It also has 4 Ethernet ports for PCs that are residing in the local area network to be connected using a twisted pair cable. I have extended one of the ports by connecting it to the switch and extending the number of the ports that I have. You could eliminate this switch. On the other side of the router, there is an interface called Internet. That interface, you can assign static IP address to it or make it a DHCP client of the ISP. Normally, that's the case. It's going to be the client of the ISP, DHCP client. So as you can see, this home router acts as an access point, acts as a switch, acts as a modem to get connected to the ISP, acts as a router to route traffic from SOHO to this other network, to this one, to ISP. ISP will take care of routing to other sites in the internet, such as this web server that I have in the internet. One of these PCs I have called admin. This is the one that I use to get connected to the home router and configure it. I go to the web browser of that PC and type the IPv4 address of the home router, uh, which is the local area part of it is 200, 200, 200. I think it's one. Go. You're going to be prompted for the user name, which is admin, and the password. By default, the password is admin. By default, this IP address is 192.168.0.1. I've already changed it. And I've changed the password too. I'm not going to reveal it. Why? This is the password for this activity. And as I click OK, I get connected to the uh, area that I can configure the home router. This admin is the name of the PC that I'm using as the terminal to get connected to the home router. On the setup tab, you'll notice that the internet part is DHCP. It was DHCP, and I scroll down, I changed it. I changed it back to DHCP. And also you notice for the local area network, it is acting as a DHCP server. It has 200, 200, 201 with this subnet mask as its own IPv4 address and subnet mask, and it starts leasing IPv4 addresses from the network 200, 200, 200, 0. I made the starting address to be leased to be 200, 200, 200, 100, and I asked the home router, do not assign more than 10 IP addresses to devices. I don't need more than that for a home. All those changes I have saved by clicking on Save Settings. If I go to the wireless, you'll notice that I kept the SSID as default. I could change this one to anything that I want. Then I have to change it on all the wireless devices. It's case sensitive. I have made SSID enabled for the home route devices that I have in the SOHO to see it and get connected to it. As far as wireless security is concerned, uh, security is disabled. I could go ahead and configure web, which is weak, WPA personal, which is weak. I can configure WPA and WPA. I cannot configure WPA enterprise. For that, I need a radius server. I can configure WPA to personal. I cannot configure WPA to enterprise. I kept it disabled for this activity. And then, as far as wireless is concerned, there is an item called MAC address filtering, which is the purpose of this activity. As far as setup is concerned, there is an area called administration. If you go there, you can change the password. Any changes that you make, you have to scroll down and click save, otherwise it wouldn't take effect. So I've already made the configuration. I've changed the password. I haven't configured any MAC address filtering. I haven't configured any uh, password, but I have changed the uh, IP addressing for the LAN, and I have changed the wireless router password for admin to access. Now, now, so as I mentioned, this network, this topology has a WRT300N home router that connects a local area network, which could be a small office, home office type of network, to internet through an ISP. The LAN part of it, on the LAN part of it, it acts as a DHCP server, assign IPv4 addressing to these devices. On the internet part of it, it is a client of DHCP server, and the ISP router acts as DHCP server to provide IPv4 address to the internet part of the home router. Now, let's go ahead and see if we can access a website on internet. The website that we want to go is on this server, and this server has the IPv4 address of 505050. Let's go to the SD1 web browser and then type that IP address or the name of it. If we configure DNS in here, we haven't configured DNS, so we type the IP address of that server 50.50.50.50 in the ERM, and we say go. We get connected to a website. It says, welcome to the Cisco Packet Tracer website. Very good. Can I ping this server from this smart phone device? Go to the command prompt and I type ping 50.50.50.50. Replies are coming back. So I can do the same thing from all these devices. I can access the website of the web server and I can ping it. Let's do it on admin PC, ping 50.50.50.50. We receive replies back. Let's see if we can go to the website on that server. We go to the web browser of this PC. We type the IP address of the server in the URL. Go, we can access. Can this server access any devices that we have in the SOHO? Let's try it. We go to the command prompt of the server and we ping one of our PCs in the SOHO. Destination host unreachable. Admin PC has that IPv4 address 200.200.100. No other PC is accessible if the communication is initiated from the internet. Therefore, the home router acts as a firewall. Communication that initiates from internet cannot reach any of the devices in the local area network. But if communication initiates from SOHO, the reply is allowed back to SOHO by the home router. Therefore, home router acts as a firewall in that regard too. Now, this is related to configuration of the home router and how it works. But suppose this device, which belongs to somebody else, and for the purpose of this activity, I've turned the wireless off on it, otherwise it gets connected to the home router. It gets close to this home router that we have in the public area. If you notice, when you try to connect to your internet from your PC or laptop at home, when you click on internet access, you'll see the SSID of all the neighboring neighbors that you have. Their SSIDs are going to be broadcast. You can see it. Now, the same is true in here, because as an access point, it emits signal in 360 degree, and some of it leaks out of the boundary, physical boundary of the home or office that we have. Therefore, if this device gets close to that home router, it is going to get connected to it. you go ahead and turn the wireless of it on, you'll notice that it gets connected. By getting connected to the home router, this device doesn't belong to us. By getting connected to the home router, it can use our internet service provider services and go to internet. It can access the devices that we have in our local area network. Let's see if it can communicate with our SD-WAN ping 200 200 200 101. Heck yes, it can. Can it communicate with the admin PC? So firewall is not working to stop this device that doesn't belong to us. It's just getting connected to our wireless router. Through that wireless router, it can reach the local area network that we have. It can use our services to go to sites in internet. For example, it can go to that web server. Let's go to the web browser of SD2, which doesn't belong to us, and type the air of that server, which in this case is an IPv4 address. It can get connected to that site. Now, one way to prevent such a rogue device from connecting to our WRT300N is to enable authentication on the home router for wireless devices. That will stop the SD2, the rogue device, to get connected to the home router. That's the first line of defense. But what if, through different ways, our password is revealed? If we are careless, we use a simple password that can be guessed at. Possible. If a virus through a malware, our keystrokes are captured and our password is revealed that way. Possible, more difficult though. What if through social engineering we provided enough information that our password becomes known to somebody that should not know that password? So if that password is compromised, even having password doesn't prevent this rogue device from connecting to the home router that we have. Okay. The second line of defense is MAC address filtering. MAC address filtering is by default disabled on home router, but we can enable it. When we enable it, we can permit devices with certain MAC addresses, or we can deny devices with certain MAC addresses, either or. Let's get connected to the home router through the admin PC so I can demonstrate on that one. Go to 200, 200, 201. Provide the username admin, password wireless. Okay. Connected to the setup page, click on wireless and then select wireless MAC address filter. You see, MAC address filtering by default is disabled. Can enable it. When I enable it, I can prevent or I can permit. These are the devices that I have myself. These are my devices. I want them to be connected. The devices that are in the public domain are not my devices. I don't even know their MAC address to prevent them from getting connected to the home router. So as you can see, prevent is not something that is useful to me at this point. Who should I prevent? How do I know the password of the passerby near my house or my office? Therefore, I go with permit. Permit which one? Permit all the wireless devices that I have in my local area network by typing their MAC addresses in here and then scrolling all the way down and going uh, save settings. Notice as I do that, this device is disconnected because only these two devices are permitted to get connected to that home router. And I use the wireless MAC addresses to configure the MAC address filtering. This is second layer of defense. Uh, Defense in depth, one layer after another to prevent this rogue device from getting connected to my home router. The first layer of defense in this case was authentication between wireless devices and the home router. Second layer of defense, MAC address filtering. Is there any other thing that we can do? Yes, there is. Let's go ahead and get connected to the home router again. We got disconnected from it by closing the admin page. 200, 200, 201, admin, wireless. Okay. Notice under setup tab, DHCP is enabled. If DHCP is enabled, it means that a device like this can also receive IPv4 address from the home router. So one thing that I can do is disable DHCP and assign IPv4 addressing to these home devices that I have manually, static IPv4 addresses. That I can do. But it could be a pain, by going through each and every one and configuring the MAC address filtering. Nevertheless, that's one thing. The other thing is to limit the number of the MAC addresses that can be listed out. The third one is DHCP reservation. If I click on DHCP reservation, you'll notice that SD1 and admin always receive the same IP addresses from DHCP server because I have made a reservation based on their MAC address. So I can type the name of the client in here, the IPv4 address that I want that client to have, for example, 102 for PC2, and put its MAC address in here, then click on add. That client also will be added to this list and will always receive the same IPv4 address from the server. And then on top of that, I need to limit the number of the IPv4 addresses that can be listed out to exactly the same number of the devices that I have. So the DHCP server in this case is going to provide 6 IPv4 addresses, and all of these devices, based on their MAC addresses, I'm going to make a reservation for. Therefore, this device, even if there is no MAC address filtering, even if it bypasses the the password that we have for authenticating wireless devices, still cannot receive IPv4 address from the DHCP server because DHCP server is already starved all the IPv4 addresses that it has, and it's already given out to whom? To these legitimate devices. That's another layer. So as you can see, defense in depth can be performed in a variety of ways. For home routers such as WRT300N, my recommendation is authentication between wireless devices and the home router, plus MAC address filtering by permitting the wireless devices that you have in your Soho. That way, rogue devices such as SD2 that are in public domain close by to your home router, they cannot use its services to get connected to it and go to internet. Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.